Hello, friends, and it's me again with another math video, which I have only done one of before, but it's still another one. This time we're going to talk about how to do binomial factoring, which you may know as foiling. So, what is a binomial, first of all? Well, a binomial is, I think it probably means like exactly two numbers, but we like to describe it as two terms, right? So one term is like one little number thingy, right? So 3x is a term and 1 is a term right here. That's our binomial. But what would happen if we multiplied this binomial by another binomial? What then? We'd have something like this. And we've got to have the parentheses. This is important because of the orders of operations, because if we just do this, multiply them right in the middle, right? Because of the order of operations, this ends up being the only things multiplied together are the 1 and the 2x, which just gives us 3x plus 2x plus 9, but we can simplify that, so it's just 5x plus 9, which is not actually the answer. We wanted to multiply one whole binomial by the other whole binomial, which is not what we just did. We only multiplied two of the terms together. So we go back to our setup right here, and what we're going to do with this is we're going to use a lot of the distribution property, which is the idea that like you multiply something by every term inside of a set of parentheses, right? So here's an example thing with only one binomial. The other one is not a binomial, right? 4 isn't a binomial, it's just a number. We want to multiply 4 by x plus 3, and what this basically means is that there are 4 x plus 3's, right? So one way you could say this is that it's x plus x plus x plus x plus 3 plus 3 plus 3 plus 3. So there are 4 x's and 4 3's, right? But that's kind of a pain, and it doesn't look that nice. Like, it doesn't make a lot of sense to look at. That's just a whole lot of symbols, right? And when you get to multiplying bigger numbers, it's really inconvenient. It gets a lot less convenient when you get to bigger numbers. It's not very convenient, but we can notice that it's the same answer if you just take 4 and x and multiply them together, and then 4 and 3 and multiply them together and add those. So a shortcut, much easier than just saying x plus x plus x plus x plus 3 plus 3 plus 3 plus 3, because of that, if you simplify that, it's 4 x's and 4 3's, so it's 4x plus 12, because 4 times 3 is 12, and that's a lot easier, right? But we want to do the property of distribution with two binomials. And how are we going to do this? Well, we're going to use this method called FOIL. FOIL is an acronym that stands for an order to multiply the numbers inside of each set of parentheses by each other. And I actually didn't know what it stood for, so I had to look that up for this video. You don't have to use the FOIL method, but it's a good way to keep track of your numbers and which ones you've multiplied yet and which ones you haven't, right? So what it stands for is first, outer, inner, last. And that means nothing, right? Those are just a bunch of adjectives. So what on earth are we supposed to do with those words, right? So first you do the first ones. And so what are the first ones? Well, what it's talking about is the first number in each set of parentheses, the first number of each binomial. So for us, that's 3x and 2x. So we want to multiply 3x and 2x together. And since 3x is 3 times x and 2x is 2 times x, what we're doing is we're saying 3 times x times 2 times x, right? So 3 times x times 2 times x. But that's kind of not my favorite way to look at it. That doesn't help me much. And you don't have to do this. Like, you don't have to consciously make the decision to do this, but it helps me to rearrange things and say 3 times 2 times x, right? And 3 times 2 is 6. And x times x, well, we don't know what x is. We can't come out with a one specific concrete value, right? Like, we can't say, x is 4, this is 16, because 4 times 4 is 16, right? But we don't know what x is. So instead of just leaving it as x times x, we say x squared, because squaring something is when you multiply it by itself. So we end up with 6x squared, right? And I'm just going to put this up in the corner, right? And we end up with our equation, right? I'd put it back to normal. There's no more red now, right? And then what's the next one? It's outer. What are the outer terms? Well, they're the ones on the outside of the equation. So in this one, for us, they're 3x and 9. And that, if we write it out, is 3 times x times 9, right? And that we rearrange it to 3 times 9 times x, and 3 times 9 is 27, and then we just add the x on, right? So it's 27x. And we've got that, we're going to go put it up in the corner, and then we go back to our original equation without any highlighted stuff, right? And the next one is inner. What are the inner ones? The inner ones are the ones on the inside of the equation, right? So one's not on the edge. For us, those are 1 and 2x. So we have 1 times 2 times x. Or, since you know that 1 times anything is just the thing, right? So you don't even have to write it out like this, but I did. So it's 1 times 2 times x, right? It's the same as 2x. So 1 times 2 is 2. Times x, 2x, right? So we're going to put this up here, and then we go back to the equation, right? And then the last one is last, and what that means is the last term in each binomial. So for us, that's 1 and 9, and that's just 1 times 9, and that's just 9, and so we add that. We add that to our little equation up there, our polynomial. It's a trinomial, actually, because it's got 3 terms. It will eventually. Right now, a quadnomial or something, but we're going to simplify it. So what we're looking for are like terms. And what are like terms? Well, they're terms that you can add together, or if they're negative, technically you could call it subtracting, but we still call it adding because it's the same. We're just adding it, just one of them is negative, right? But that's something to go into later. So we're looking for ones that we can add together, right? You can't squish 9 and anything together because 9 is a constant, and we don't have any other constants. It doesn't have a variable on it, and everything else has a variable on it, so 9 stays as it is. We've got 3 with x's on them, right? But see, we can't add 6x squared to anything because the x is squared, and that means that if we try to add it to something, the thing, whatever we do, it won't end up right. You can't squish together x squared and anything, but you can squish together the 27x and the 2x because they are like terms. They have the same variable situation, right? We just take those, we just take 27x and 2x, and we're like 27x plus 2x, right? And that adds up to 29x. So our final equation that we end up with is 6x squared plus 29x plus 9x. And there you have your factored binomials. Except they're not a binomial anymore. But that's a good time, and you can ask me questions if you want in the comments, or I've got some social medias link on my YouTube channel page, right? Or if you just happen to know me, ask me. I will explain it to you, and I'll do my best. Thank you for watching this. I hope it helped you.